All right, this is a video for assignment 8, probability and statistics, dealing with coefficient of determination, your R squared, and your SE, your standard error of estimate, and how to find those things. The first thing, I have this chart made out already. I'm going to do this first one in 2 different ways. I'll do it with this chart, then I'll do it with the other chart with the other formula, so that you can see both ways. But I'm not sure, maybe our book has a typo or something, because the other formula isn't always coming out exactly like it should. We'll see how it comes out this time. I've already set up this chart for number 15. They gave us the regression equation, so we have that there. And we're looking for the standard error. The other thing that we're going to do is we're going to find R and everything. And if I go on my calculator, clear that, go to stat, edit. If I go over to list 1, I've already put all these X's into list 1 and all the Y's in list 2. That's one of the things you should do. Again, put them in these lists, because it's going to help us figure out a whole bunch of this stuff. Like it'll help us figure out R and R squared and make that easier, because we can just use the linear regression on our calculator instead of figuring it out longhand. First thing we got to figure out to do this chart is we have to figure out the predicted Y for each of these X values using this linear equation. So all I'm going to do on my calculator, I'm going to clear all this off. Let's see. I want to make sure I don't clear anything. So I go in here, and to make it easier, just do this. First one we're putting in is 754, so I'm going to put in 1.9. We really don't need those 2 zeros in there every time. That's just extra stuff. 1.9 times, our first one is 754 minus 411.976, hit equals, and that tells us, I'm going to round it off to 2 decimal places since we're dealing with money, 1020.62. So our predicted Y here is 1020.62, and I probably should have mentioned that about this problem. This is comparing the average weekly wages of a state employee to average weekly wages of a federal employee. So I'm guessing that they're looking at 2 people who have the same title of job, but one works for the state, one works for the federal government, and comparing their wages. So we put in that number. Now the next thing, to make this easier, if you hit second and enter, it'll go back to that equation, and we can go right over here to 754 and get rid of it. And this way we don't have to type all this in over and over again. We're just going to leave that in there, and in place of 754, put in 770, hit enter, and it tells us 1051. I'll try to move this over here so I can write 1051.02. Then we hit second, go back, place 770 this time. We're going to put in 791, hit enter, tells us 1090.92. Do the same thing for the next one, hit second, enter, and this should make it a lot easier as you're doing these problems. If you're doing this, put in 812, hit enter. Our predicted value would be $1,130.82 about. The next, we put in 844, so we hit second, enter, go back to 812, put in 844, hit enter, gives us 1191.62. Second, enter, go back to 844, and this time put in 883. Hit enter, gives us 1265.72, and that's all of them. So that's all your predicted Y's. what we're predicting that your federal worker should make, weekly wages, given that the state worker makes this amount that we have in our X list over here. Now all we're going to do to find this next column is do all these subtract this column minus this column and put it right here. So we got 1,000, I'm going to clear this, 1,001 minus 1020.62, and I end up with negative 19.62. Then I do the next one, 1043 minus 1051.02, and I end up with negative 8.02. Next one, 1011 minus 1090.92. I end up with 20.08. 1151 minus 1130.82. Get 20.18. 1198 minus 1191.62. You end up with 6.38. And then the last one, 1248 minus 1265.72. You end up with negative 17.72. So that's our next column there. Now to get this last column, again, to make it easier, because we want the sum of this last column, because that's our variation that we can't explain, our unexplained variation. That's the column we want to be able to find our standard error. To do it, all I'm going to do is I'm going to take this column. I'm going to forget all about the negatives, because it doesn't matter. When we square something, it's going to end up being positive. I'm just going to take this column and I'm going to square each one, and I'm going to add them all together, and I'm going to do it all right here in my calculator instead of writing all of them down separate, so I just get an answer down here. And as long as you're careful, it should work out all right. So I take 19.62 squared plus 8.02 squared plus 20.08 squared plus 20.18 squared plus 6.38 squared plus 17.72 squared. So I've just took every one of these, squared each one, and then I'm adding them all together and let my calculator do all the work, so I don't have to punch in a bunch of different stuff over and over again. And I end up with 1614.4064. I'm not going to round that off. I'm just going to leave it that way. Then the next thing we're going to do, we're going to find our standard error of estimate. That's our SE. That formula is this number on top, 1614.4064, and on bottoms are degrees of freedom, which is just n minus 2. Well, this time n is 1, 2, 3, 4, 5, 6. So 6 minus 2. And I'm just going to plug that into my calculator. I'm going to hit second, square root, 1614.4064 divided by 6 minus 2 is just 4. Where some of you may have trouble again, I need to put that parenthesis in there to end my stuff. You may not have to. You have to know your calculator. I hit enter and I get 20.0898, so on, so on. So about 20.09, I'm going to say. That's our standard error. That's one of the answers that they wanted. To explain this, remember that's going to say when we explain it, the standard error, sorry, I wrote cursive there, of estimate. We always start off with that. Of the, and then the next part is the Y. So of the average weekly wages, the Y was the federal. So for federal workers, for a specific, and then that's where our X comes in, for a specific average weekly wage for state workers is about, and this is in terms of money, so about $20.09. That would be our explanation of our standard error of estimate. That was all part B. Part A, they wanted you to find the R squared, the coefficient of determination, and we can do that just by on our calculator here. If we have them in the list, we can do that by going to stat, going to calculate, going down to linear regression, hit enter, and I put mine in on list 1 and list 2, so I'm going to hit second 1, comma, second 2, and it's going to pull up all that stuff for us. All we care about this time is that coefficient of determination, the R squared. So R squared equals 0.963, we'll say. And then our explanation of that R squared, remember that means that we bumped the decimal over 2 places. 96.3% of the variation, and I'm not explaining this very well, but this is good enough for us. 96.3% of the variation is explained. Normally, to explain it a little better, you'd say 96.3% of the variation in wages of the federal government employees can be explained by the variation in wages for state employees. So you'd go through all that. I'm not worried about that right now. 96.3% of the variation is explained, and then that means that about 3.7% of the variation is unexplained. So that's number 15. That's the first way. I'm going to do it the other way also and see what we come out with. All right, this is the other. I just redrew the chart, but now we have x times y, x squared, and y squared in the chart instead of the other stuff that we did on the other chart. Neither one of these ways, I'm not sure which way is the best way to do it. I'd say the first way is probably the best way, because this way seems to give us a different answer sometimes than what we actually want. We'll see what happens here. I don't know that one's a whole lot easier than the other, but we'll see. That's sort of up to you. As I researched this, trying to figure out maybe other ways to teach you how to do it, to find the standard error of estimate, there are several different formulas that you could use to find it if you look online, and this book gives you 2 of them, and we'll see. again, I don't know which method is best. That's really up to you. The bad thing is I'd probably use the first one because that's the one that I'm going to lean towards, just to make sure that you're getting the same answers that I'm getting. So on this one, I've already got all this list in. If I put all these lists in my calculator on list 1 and list 2, which I've already done, I can find the sum of all the x's, I can find the sum of all the y's, I can find the sum of all the x squareds, find the sum of all the y squareds. So I can find a whole bunch of this stuff that I need just from the calculator, just putting it in. The one thing I can't find is I can't find x times y. So all I'm going to do for that is I'm going to type this in. I'm not going to write down each answer separately. I'm just going to type in this times this plus this times this and do it all as one thing. And hopefully I get it right. Hopefully I don't mess up and hit something wrong. So x times y, you're just putting in 754 times 1001 plus 770 times 1043 plus 791 times 1111 plus 812 times 1151 plus 844 times 1198 plus 883 times 1248. That's the last one. I hit equals, and it tells me that the sum of all these x times y's is 5484373. So 5,484,373. So I don't really need this whole column here. I don't have to punch it in all separately because that's the only number I need, is the sum of all those. Then to find the other stuff that we need for the other formula, if we go to stat, go over to calculate, we want the one variable stats. So we want number 1, and we're going to figure it out for list 1, which is our x's, and that tells us all this stuff. So that tells us x bar, the mean of the x's is 809. Tells us the sum of all the x's, which is right here, is 4,854. Tells us sum of all the x squareds, which is this column right here, is 3,938,466. So 3,938,466. So that's all the numbers that we need off of this one. Now we're going to go back in there and hit stat again, calculate 1 bars, and this time we want to do our y's instead of our x's. So I'm just going to hit second and then put in list 2. That's where my y's were, and that's going to tell us all the y information we need. So we know that y hat, or not y, y bar, I think I said x hat up here too, x bar, the mean, and y bar, we know that, I know this says x, but this is our y variables, is 1125.33, and the sum of all the y's is 6,752. That goes right here. And then the sum of all the y squareds is 7,641,680. So 7 million and something. And then we're going to take that and we're just going to punch it into the other equation, which is this. I just wrote down this equation. So we need the sum of the y squareds, we need the b, we need the sum of the y's, we need the slope, the m, and then the sum of the x times the y's. Remember, this is your m, that's your slope, That's your B. Don't forget that B here is a negative, so we'll have to make sure we put that in. So the sum of the y squareds is this number, 7,641,680, minus B is this number, negative 411.976. Sum of the y's is this number, 6752. So we're multiplying those two together, minus the slope, which is, I'm just going to put in 1.9. We don't need all those extra zeros, times the sum of all the x times y's, which is that number, 5484373. So that's all on top. On bottom, we just got n minus 2. The n was 6. So 6 minus 2 on bottom. We're going to put all that into our calculator. The way I put it in my calculator is I just put in the top, leave that number in there, then put in divided by. On bottom it's just going to be 4, so divided by 4, and then I actually hit second square root and punch that number back in there to try to be as precise as possible. So 7,641,680 minus, hit plus, minus, we want a negative, so I'm going to put a parenthesis here, negative 411.976, close the parenthesis, and I can put these parentheses in for the multiplication, and it'll do this, the calculator knows to do the same thing, so I'll just put another parenthesis, 6752, close that parenthesis, minus parenthesis 1.9, close that one, open up a new one, 5484373, close the parenthesis. If you don't like putting in all those parentheses in your calculator, if it confuses you for whatever reason, then do it a different way. It's still times is all parenthesis next to a parenthesis means. So I have all that in there, and I'm just going to hit equals, and it gives me that number. And then I'm going to take that number and I'm going to divide it by our bottom, which was 6 minus 2 or 4. So divided by 4, and I end up with 758,313. Now once I have that number, I need to take the square root of it. So I'm just going to hit second square root, and then I have that number right there, so I'm just going to retype it in, 758.313, and I end up with 27.54. So our SE here ends up being about 27.54. And you'll notice, again, this is what I'm not sure about on these two different formulas, you'll notice that that's a little higher than what it came up. The other one came up 20.09. So here we're saying that the standard error using this formula, using this method, is about $27.54 instead of $20.09. I'm not sure why they're different there. Just two different formulas. I'm not sure exactly what it all means, but that's the case. So I would highly suggest next week we'll probably have a short test or quiz over chapter 9. I would suggest using the other method just to make sure that you're on the same line as I am. I'm not going to do for this one, I'm not going to do all the rest of it. I'm not going to do the explanation or finding the R's or any of that, since we've already done that. It's just the other way, the other method to find the standard error of estimate. All right, this is number 17. I've already made out the chart for it and everything. Same idea here. On this one, I'm not going to do it two different ways. I'm just going to do it this one method. Again, the hardest column is this column right here, finding the predicted Y. But if you take your calculator, and I'm going to try to move this over so I can get my calculator in here so you can see it. Again, if you punch in, you're going to punch in this formula, put in each X, and if we use our calculator and just do it down through here, it makes it somewhat easier. So we got 0.45 or 415 times, we'll put in our first X is 1038 minus, is this one minus? Yeah. Minus 186.626, hit equals, and we end up with 244.14. I'm just going to round it off to two places. Then if we hit second, enter, we can go right back in there, and in place of 1038 we're going to put in 987, and we have that extra number. We just have to get rid of that extra number, so hit delete, hit enter, you end up with 222.98. second, enter, go back up into that same equation. This time we're putting in 990, hit enter, it's 224.22. second, enter, go back up, go over to 990. This time we're putting in 1108. 1108. This is going to mess up everything, so we're going to have to just type in this last part again, and I hit plus again, minus 186.626. It gives us 273.19. second, enter, go back up to the equation, and we're going to take out the 1108, put in 1236, just hit enter. This time it'll work in 326.31. second, enter, go back up to the equation again, 1366, hit enter, 380.26. second, enter, put in 1426 this time, 405.16. So that's all our predicted Y's, just plugging them into our regression equation and getting what we're predicting it should be for this X off that regression line. Then again, all we're going to do is we're going to take these numbers and we're going to subtract these numbers. So 211 minus 244.14, and we end up with negative 33.14. 194 minus 222.98, negative 28.98. 231 minus 224.22, you get 678, 6.78. 307 minus 273.19, 33.81. 381 minus 326.31, get 5469. Oops, 381, okay, I did that right. 396 minus 380.26, you get 15.74. 354 minus 405.16, negative 51.16. So that's that whole column. So that's just y, what we got in our data, minus our predicted y's. Now we're just going to take each one of those and square them. And again, I'm going to put all this in my calculator just as one thing. I'm not going to do each one. If you want to do each one, then add them all up, that's fine. I'm going to hit clear here. The negatives don't matter because we're squaring it, so it's going to end up being a positive. So I'm just going to type in each one of these squared plus the next one. 33.14 squared plus 28.98 squared plus 6.78 squared plus 33.81 squared plus 54.69 squared plus 15.74 squared plus 51.16 squared, hit equals, and that gives us this total down here. So 8,983.2738. I'm not going to round that off, I'm just going to leave it that way. And then we're going to put that into our formula. That's the top part of our standard error of estimate formula. 8,983.2738. Then on bottom is n minus 2. Well, n this time is 1, 2, 3, 4, 5, 6, 7. So 7 minus 2 on bottom. Remember, this is your unexplained variation. That's what we're trying to come up with. That's what goes on top of the standard error formula, is the unexplained variation. Then on my calculator, I'm just going to type in, I already have that number in there. So I'm just going to hit divided by 7 minus 2 is 5. So divided by 5, and I end up with this number. And I got to take the square root of that. So on my calculator, I'm just going to hit second square root, and I'm going to type in that number. And I end up with 42.39. And for our explanation again, we're just going to say the standard error of estimate, and then we put in the y, whatever the y value was, and this time it was the corporate income taxes of corporate income taxes. And again, we should probably explain this a little better because it was in billions of dollars, and I'm not writing it all out completely like I probably should. Corporate income taxes for a specific, and then we put in our X, individual income tax. It should probably be gross, like gross income tax in there, whole thing. Is about 42.39, and that's money, but it's in billions of dollars. Again, that's part B on this one. Part A, they wanted you to find R squared, the coefficient of determination. I put in all these numbers. Again, I didn't say it at the beginning, but I put in all these numbers on list on my calculator. So all I'm going to do is go to stat, calculate, and I want to go down to linear regression. We could actually, you'll notice when I hit this for these numbers, I put it, we want that. I put it in the third list, comma, the fourth list. We'll notice here our A is 0.4147. That's that slope right there. That's where they came up with it at. Then our B is negative 186. Same number is right here. So we could have used this and got our regression line equation ourselves instead of them giving it to us. And you should be able to do that. But our R squared, our coefficient of determination, is 0.789. Our explanation of that is that about 78.9% of the variation is explained, can be explained. And again, I'm not writing this out. It can be explained. About 78.9% of the variation between the predicted and then so on can be explained. And then if 78.9% can be explained, then we subtract that from 100, and we get about 20.1. 20 is it? 100 minus, make sure I'm not doing this wrong, 78.9, 21.1. So about 21.1% of the variation is unexplained. If you remember the other sections, then that means that this isn't near as good as that first one, because 21% of the data, or the variation, we can't explain it, whereas the first one was a lot less. It was only like 6%. So that's number 17. All right, to find the intervals on 23 and problem 25, I believe it is. To find these intervals, we're going to construct the indicated prediction interval and interpret the results. Most of this information that for this formula, we already have it. The only thing that we don't have is our critical value, which is TC, and we're going to get that by using our degrees of freedom, which for 23, which goes with number 15, was our N was 6. So our degrees of freedom are 6 minus 2, which is 4. We're going to use that, and they tell us our C, our confidence level that we want on 23 is 99%, so 0.99. And they also tell us that our X sub 0, the number that we're predicting, using to predict, is 800. So we need that X sub 0, that goes in here. We need this TC. Everything else we found in other things are all on the calculator, and we'll get all those, the X bar, the sum of the X squareds, sum of X's, and then we'll have to square it, so on and so on. So we'll plug in there, but first thing we're going to do is go to this chart, T distribution, and we're going to use 4 and 0.99, 4 and 0.99. We go over here, that's 4.604. Can't hardly see that. So we go from 4 over to 0.99, 4.604, that's right there. So that's our TC, 4.604. Our SE we found when we did problem 15. And I'm going to use this one. We found our SE, it was 20.09. So I'm going to stick that in there. We got 1, that stays the same. 1 over n. N this time was 6. Plus on top. We got n, which is 6, times x sub 0, which is 800. Now these other three numbers we're going to get from our calculator. And if we did it the second method, if we found the SE the second method, then we'd already have those numbers. But as long as we typed all the numbers into our list on our calculators, which I did on this one, all we got to do is go in and we're just doing it. We just need the x stuff, x bar, sum of all the x squareds and the sum of the x's. So I know that my x's for number 15 were in list 1, so I'm going to hit stat, calculate 1 bars, and it was in list 1, so I just put in list 1, and I have this. X bar is 809, so minus 809 right here. Squared, n is 6, times the sum of the x squareds, which is right here, 3, 9, 3, 8, 4, 6, 6, minus, here's where you got to sort of be careful. You want the sum of the x's, which is this number right here, 4854, but you got to square that. You don't have to square this one because that's the sum of all the x's squared, all the x squareds, which is that number there. This one we actually have to take the sum of the x's and then square it. When I do this problem on my calculator, I like to do the top part here first, then the bottom part, then do the division, and then have that number in the calculator and add this number, then add that number, then take the square root of the answer I get and then times that by this. So you got to do it in sort of separate steps maybe. So first thing I'm going to do is this top, 800 minus 809. I know that that's a negative 9. And we're going to square that, and I know that that's 81. 9 squared is 81, and then we want to times it by 6. So if you wanted to punch it into your calculator, you could punch it in just like this, 6 parentheses 800 minus 809, close the parenthesis, squared, hit equals, and it tells you that that whole top part right there is 486. Then I'm going to do all the bottom, and you could plug it in just like it is right there also. As a matter of fact, well, maybe I won't do that. I was going to say you could just hit divided by and then do it, but let's do it separately. 6 parenthesis 39 38 4 66, close the parenthesis, minus 4854 squared, hit equals, and this whole bottom part here ends up being 69,480. Now I just take that 486 and I divide it by that. So 486 divided by 69,480, and I end up with this number. Notice I'm not doing anything with that number. I'm just going to leave it right there in the calculator, because next thing you're going to do is you're going to add on these two things right here. So I'm going to say plus 1 divided by 6, and the calculator knows what order to do everything in, so it'll do it, and you hit equals, and you end up with that number, 1.173666, or 661485, so on and so on. Now all I'm going to do, I have that number right there in my calculator because I want to be as precise as possible. So I'm just going to take that number, and I need to take the square root of it, so I'm going to hit second square root, and I'm just going to type all of that in, 1.173661485, close the parenthesis, hit equals, I get this number, and then that's what all of this under the radical, under the square root there was. Then I'm just going to times it by both of these numbers, so I'm just going to hit times 20.09 times our critical value here, which was 4.604. Hit equals, and I end up with 100 .2. So E equals 100.2. Remember that E, that's our margin of error. Now what we wanted is we want the interval. So our interval is y hat, and that's another thing, I got to find y hat, so let's do that first. So we want y hat. Well, y hat's going to equal our equation from number 15 was this equation, 1.900x minus 411.976. Well, all we're going to do is we're going to plug in there for x, and that's where our x sub 0 goes. So 1.9, I'm going to leave off the 2 zeros, times 800 minus 411.976. I'm just going to punch that into my calculator just like it is. 1.9 times 800 minus 411.976, hit equals, and I end up with y hat equals 1108.02, somewhere around there. I'm going to use these two numbers to make my interval. It's y hat minus E is the low side, and then y hat plus E is the high side. So on the low side, y hat 1108.02 minus 100.2. And then on the other side, 1108.02 plus 100.2. So on my calculator, I'm just going to punch this in, 1108.02 minus 100.2, and that gives me 107.82. 0.82, not 87, and 1108.02 plus 100.2 gives me 1,208.22. And then our explanation for this. So this is our interval. And our explanation is that we can be 99% confident that the average weekly wages of federal employees will be between $1,007.82 and $1,208.22 when the weekly average for a specific state employee is $800. That's our X sub 0, the number that we were predicting off of. All right, for 25 to get the interval, first we got to find E. I lost my chart. I've written down all this stuff. They in 25 they said they want us to predict at 1250. The SE that came from number 17 was 42.39. For number 17 there was N or N equaled 7. And they said that they want our confidence interval to be 0.95. So first thing, DF, our degrees of freedom, are N minus 2, so that's 5. We're going to use that and this and use the chart. So 5 and 0.95 and use the chart here. 5 is right here, 0.95 we go over is right there. Looks like 2.571. So that's our critical value, our TC. We're going to times that by the SE, which we figured out was 42.39. And we're going to times that by a big long radical 1 plus 1 over N, which was 7, plus N, which is 7, and XO, which is 1250, minus, I'm just going to put the rest of this in here, and then down here we got N is 7 again, times, we got this number that's going to go in there, minus, and then some number that's going to go in here, squared. These three numbers we're going to get off our calculator. If you put them all into your list, which I did, so I put them into my list. This one for number 17, we're just looking for the X's. I put it in list 3, so I'm going to hit stat, calculate, again one variable, 1 bar stats. Second, I want list 3 this time because that's the list that I put all my X's in for number 17. Hit enter. And it's going to tell me all these things. X bar goes on top here. That's 1164.43. And then on bottom, this one for the equation is the sum of all the x's squared. That's this big number. I might have to write small here. 9686505. So 9,600,000 some. And then here we want the sum of all the x's, which is right here, 8151, and we're going to square that. I'm going to clear all that off. Again, I'm going to do this top, do it just like it is right there. 7 parentheses 1250 minus 1164.43, close the parentheses, and I want to square that. It equals, so this top number is 51,255.57. Sorry, that just seemed awful big. Then on bottom, I'm going to do all this, just plug it in like it is right there. 7 parentheses 9686505, close the parenthesis, minus parenthesis 8151, close the parenthesis, squared. The bottom number here ends up being 1,366,734. I'm just going to take those two numbers, divide them. So 51 255.57 divided by 1366734. I get this number. I'm just going to leave it in my calculator, and I'm going to add on the 1/7 and the 1. So add on plus 1 divided by 7. Hit equals. This is the number that's underneath our radical now. So I'm just going to hit second square root and type all of that number into the calculator. 1.180359371. I get that. That's the number that's coming out of the radical, so that's all of this. And then I'm going to just times it by these two. So times 42.39 times 2.571, and I end up with E equals 118.41. Then I got to find y hat. The x that we're predicting off of this time is 1250. So I'm just going to take our regression equation that we had and plug in 1250 in place of x. Plug this into my calculator just like it is. 0.415 parentheses 1250, close the parentheses, minus 186.626, hit equals, and I end up with y hat equals 332.12. we'll round it off to there. Then we're going to take y hat to do our interval, y hat minus our e, y hat plus our e, our margin of error. That's going to give us our interval. So I got 332.12 minus 118.41 gives me 213.71 on the low end, and 332.12 plus 118.41, 450.53 on the high end. Then when we go to explain this, we can be %95 confident and I gotta read back, see what the problem said again. 95% confident that the corporate income taxes will be between and this is in billions of dollars. I'm not going to write out the whole number. So about 213.71 and 450.53 billion for when the individual income taxes collected are 1,250 billion. That's our X sub 0 there. So that's our interval. We're saying we're 95% confident that for that certain year that the federal income tax collected from corporations is going to be between those two numbers, given that the individual taxes collected that year was about 1,250 billion. Sorry this is so long. You guys wouldn't know it, but in between making this video, my son had a flat tire, so I had to stop the video and run out and help him out on 35 change his flat tire. And then I got another phone call that one of my friends was just in a car accident, so I had to stop several times and made it a little longer than it has to be.